Any suggestions? Yes. 3x minus 7 over 4 equals 4, 3. How will you solve the first equation? What will you do? Very first step. What will be that? First step. Very good. By 4. So 3x minus 7 equals 8. So 3x equals 15. So x equals 5. The same way, 3x minus 7 equals negative 8. 3x equals negative 1. So x equals negative 1/3. So you can write the solution set as negative 1/3 comma 5 with braces. Let me know if you have questions. If you finish, please start working on this. The absolute value of 6x plus 1 equals the absolute value of 15 plus 4x. So the absolute value of 6x plus 1 equals the absolute value of 15 plus 4x. Yes, please. Anyone?
6x plus 1 equals 15 plus 4x, and the other one, 6x plus 1 equals negative 15. Well, it's parentheses. Yeah.
Yes, I wanted to show it to everyone, and then, yes, you can do it in one step if you want to, but I wanted to remind everyone that these are the two options. So, first equation,
I got 2x plus 14.
okay, so I moved 4x and I get 2x equals 14 indeed, so x equals, very good, excellent. Now I have to rewrite the second equation, which is 6x plus 1 equals negative 15 minus 4x. So yes, I will move x and I will move 1. So it's negative, it will become positive 10x, and negative 15 minus 1, negative 16. So x equals negative 16 over 10, or negative 8/5. Simplified by 2, in other words. So the solution set, negative 8 over 5, 7. So this completes chapter 9. I will be honest and tell you that the first 5 chapters in sections in chapter 10 are no fun. I wish I could make them fun, but I can't. It's all about rules. Rules for radicals. Okay? Any questions on any of the problems we did from chapter 9? Okay, chapter 10. Radicals. It's a major topic. It's a major topic in mathematics. There are many rules that are applicable here. Not all of them will have future, in the sense some of them you will not see them again, not even in calculus. I will mention them, and I will try to minimize the examples for those problems that are just some rules, but we're not going to see them again, really, at least not frequently. So let's start. with, I'm just going to present the most important rules, and then we'll go back to the book and we'll choose problems. First of all, what is a radical? Notation, first of all. So this is the notation for a radical. I'm going to put n in here. I'm going to put a and power m. So this is a radical notation. Of course, every little piece has a name, obviously. This is extremely important. The radical cannot exist without this. And this is called index. The index cannot be anything. So n, or the index, can be 2, 3, 4, 5, and so on and so forth. It cannot be 0.3. It cannot be 1.9. It cannot be 1. It cannot be 0. It cannot be -3. The way we define radicals. Now, there are situations in which we will raise numbers or quantities to decimal numbers. So that will be possible. But for now, we're going to define radicals. A radical is this symbol that has an index, and the index starts at 2. 2, 3, 4, 5, not 4.3, not 5.9. This quantity, anything you see under the root, is called radicand. Radicand. Of course, the radicand has a base, which is a, and it has an exponent, which is m. And what is this? This is the radical symbol. This. That's how we represent a radical. So I'll say radical symbol. Now, what is important to know is that any radical, this is extremely important. This part is very important. So note, any radical can be expressed, or it can be converted, whatever you want to write. Any radical can be expressed as an exponential expression with, and this is super important, a fractional, we say, fractional exponent. So it's an exponential notation that has a fraction as exponent. One more time, note, very important. Any radical can be expressed as an exponential expression with a fractional exponent. The exponent is a fraction, not 5. Or you can say, but 5 is a fraction. Yes, but 5 over 1 will not change it into a radical if the exponent is 5. And I'll put comma and vice versa. What does that mean? Any exponential notation with a power that is a fraction can be changed into a radical. So let me give you a few examples, and let me write the general form of what I just said, and then I'll give you examples. So, what I forgot is to write how we read this. I didn't write it how we read it. Okay, here's how we read the whole thing. The whole thing. The nth root of a2 raised to the mth power. The nth root of a raised to the mth power. The nth nth root, right here, the nth root of a raised to the mth power. Okay. So therefore, the nth root of a to the mth power, like I mentioned in the note, any radical can be expressed as an exponential notation. Here's the base, the same base, and the power is an exponent, and the power is a fraction. The numerator is m. The denominator is the index. So if I say the cube root of a to the second power, can anyone change this into an exponential notation whose power is a fraction? What if now I ask, please change a to fifth into, because it's the same with a root. Which root, which index? The fifth root of a raised to the second power. So we notice that any radical can be changed into an exponential notation as long as it has, and remember, the power must be a fraction. And if I'm given an exponential notation with a power that is a fraction, I can change it into a root. Okay? Now, by convention, when I say the square root of 5, I mean this. But we don't write it. So we don't write this. We just write the square root of 5. Another example, the cube root of 3. Another example, the fourth root of 7. Another example, the fifth root of 9. And I can go on forever. Now the question is, what do these mean? What does the square root mean? What does the cube root mean? And the other. So let's start with the square root. The square root of 5, yes, very good, if you want to write it as perfect, is 5 to 1/2. But what I had in mind was to ask you, what is the square root of 25? How do I know that it's 5? I'll say 5 since this number raised to this power is 25. 5 raised to this power, the index, equals 25. Now what about the cube root of 27? The cube root of 27 is 3, since 3 raised to this power is 27. The cube root of -8 is since to the third power is -8. So what do I mean by these 3 dots? Very good. It's -2, bless you, since -2 raised to the third power is -8. Okay, one more. The fourth root of 16 is since to the fourth power is 16. 2 indeed. And we can go on forever. But of course, the higher the index, the more difficult it is to figure out the root. Okay. Now let's say I have to find the fourth root of 3 for whatever reason in a word problem, which we will have soon, but not immediately because we need 5 sections of rules to go through. How do I determine this? Okay, here it is. What is the power? When I'm asking myself, how do I determine the fourth root? I'm going to ask myself, what is the power? 3 raised to which power? Very good. 1/4. And here's what I get. 1.316, so on and so forth. There is another way. In here in math, you have this option. But you have to put the index first and then select number 5. I never use it myself. I always change it into a power. So let's say if we want the same thing, which is I have to punch in 4 first. I go to math. I scroll down to, or I just pick 5. It's up to you. And then put 3. Now, I would normally, in my own calculator, not here, I would put parentheses around 3. But this software allows us to do it without parentheses. So you have several ways of determining the fourth root, or any root you want. Any questions? I only use the first one. That's my preference. I punch it in the calculator like this, with a parenthesis and a caret and parenthesis 1 divided by 4. That's my preference. Instead of going to math and putting and selecting and yada yada, for me, this is easier. It's up to you. Any questions? Okay, so this was our first rule. What is the first rule? That the nth root of a to the mth power, this is a general situation, equals over n. This is our first rule. Here's our second rule. This is, for simplicity, I'm going to use the square root, but it's the same rule for the cube root, the same root for the fourth root. Everything is the same. But for simplicity, I'm going to write the square root of a times b. So if the radicand is a product of 2 or more factors, but a product, then we are allowed to write this. So the square root of a times b is the square root of a times the square root of b. This is a very important rule. This we will be using all the time. Now the third rule, what do you think about this? When the radicand is a ratio, a wild guess. What will this equal to?
The square root of a over the square root of b.
Absolutely. Now number 4 is even more important than everything we discussed so far in this chapter, because it's a very common mistake. The square root, or any index, of a plus b does not equal the square root of a plus the square root of b. So if you encounter something like the square root of 9 plus 4, you have to write the square root of 13. You cannot write the square root of 9 plus the square root of 4. This is a common mistake, and it's actually a terrible mistake. So how do you remember this easily, I think, is that a product can be split. A quotient can be split. A sum under the square root or any root cannot be split. The same thing with the difference. If I have the difference here, I cannot split it. I cannot simplify that, ever. So these are very, very important rules. All of them, all these 4. 5. Five is a very important rule. Bless you. Very important rule. Here it is. Let's talk about the square root of x squared. You can say, yes, you will say it's x based on the first rule, 2 over 2, right? 2 over 2, which makes x to which power? Right. And I will say this is correct only if x is greater than or equal to 0. Some time ago, we graphed this and you had it on the quiz, on the test. Do you remember the function on the test, the square root of x plus 3? And many of you did a very good job with it. And you came up with this, right? Because you wrote x plus 3 greater than or equal to 0, which makes x greater than or equal to negative 3, which makes the domain negative 3 to infinity. And then you graphed something like this. And I was very happy to see this. And I also asked, what is the range of this function?
0, comma, 30.
Very good. So here's what happens. Every time we take the square root from a quantity, this is the square root function, right? The square root was this. We graphed the square root of x a long time ago. Every time I have something like this, the square root, two conditions have to happen, have to be fulfilled. This quantity must be positive under the square root or any even root. And this quantity must be positive. So the square root or the fourth root of the sixth root are not what I like to call friendly roots. They're not. Two conditions have to be fulfilled. This quantity must be positive. This quantity must be positive. So therefore, 6, when I'm told x can be any real number, and I'm asked to find the square root of x squared, I can no longer write x. I can write x only if I know that x is positive or 0. This will work. But if I'm told that x can be any real number, I can no longer write x because real numbers are also negative. So if I write x here, and x is negative 3, negative 3 squared is 9. The square root of 9 is not negative 3. So I have to make an adjustment to this. Can anyone tell us from chapter 9, what will be the adjustment that we need to make? Absolutely. Thank you. Now this is true for any real number. This guarantees that the left-hand side has a quantity that is positive under it, and it guarantees that the right-hand side is positive because the absolute value makes it always positive. Yes?
Can you read what number 6 is?
X can be any real number. If x is positive, I don't have to worry about absolute value. There is no need for an absolute value on a positive number. But if x can be anything, then I have to make sure that the answer is always positive. Now let's stop for a moment and look at some problems, because now these rules are piling up and we're not using them yet. So let's more rules a little bit later. So I want to stop and practice. So I'm starting on page where is it? Page 593. Okay, let's start with problem 12. The square root of 64y to the 20th. And the question is, assume that variables represent positive real numbers. When I'm told that the variables represent positive real numbers, it means do not worry about what? Do not care about absolute value. Everything is positive. No worries. Okay. Of course, I will only worry when the index is even. I'm going to talk about odd indices a little bit later, after a few examples. I'm allowed to, since this is a product, and I have rule number 2, I can write the square root of 64 times the square root of y to the 20th. Then I know that the square root of 64 is what number I squared to get 64? 8. Now I have rule number 1 for this. Y raised to which power? 20 over 2. And this is the simplified form of this radical. I used 2 rules here. Let me show you the rules again, where I have them. Okay. I used this rule for the square root of y to the 20th. And the square root of, and I used this rule for the square root of 64. 64, 8. Why? Because 8 squared is 64. Okay. Number 19. The cube root of 64 is, since, bless you, which number I raised to the 3rd power to get 64? 4. Because 4 to the 3rd is 64. Okay, 28. The cube root of negative 64 times x to the 6th. Again, I'm going to use 2 properties here, or 2 laws, or rules. I have the cube root of negative 64 multiplied by the cube root of x to the 6th. I am allowed to do this because the radicand is a product. And now I'm asking myself which number I raise to the 3rd power to get negative 64, and the answer is negative 4. And now for this one, I use the very first rule we discussed. I copy x, and the power will be 6 over 3, which is 2. And this is it. I lost track of it. I think this was 13. Okay. Oh, yeah. Let's look at the cube root of negative 1. Because I see on many tests, homework, final exam, students write the cube root of negative 1. That's it. No. What number I raise to the 3rd power to get negative 1? Negative 1. Negative 1 is friendly. Or 1 or so. What about 31? The 4th root of negative 16. What number I raise to the 4th power to get negative 16? Say it again. Of course. We just mentioned that. If the index is even, the quantity under the root must be positive. If the quantity under the root is not positive, we will have to write not a real number. And if you want to write yourself a little note, I'll say chapter 11. That will come into play, but also in chapter 10 at the end. Yes.
I remember something about an I.
Yes. 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 This will be at the end of this chapter and also in chapter 11. So the square root of negative 1, although is not, we know it's not a real number, it will be called or denoted by I. We will talk about this, and this is the imaginary unit. There's nothing you need to write down right now about that. Okay, 41. 256 x to the 8. The 4th root of 256 x to the 8. Again, I will apply two rules here. First, I will say I'm allowed to split it because it's a product. Then I will ask myself which number I raise to the fourth power to get to 56. 4. And then I know how to change this into an exponential notation. I copy the base, and the exponent will be 2. 8 over 4, which is 2.
Do you have to separate them?
No. No. If you can go ahead, directly from here, I'm fine. Okay. Now we are getting into the absolute value situation. Problems 43 through 54 on page 594 are telling us this. Simplify. Assume that the variables represent any real number. Okay, when I'm told that x is any real number, there are a few options here. So please pay attention for a second. When I'm told x can be any real number, I could have 3 options, nothing else. Here's one option. When the index is odd, the answer can be, so this is positive, 0, or negative. The answer is positive, 0, or negative. No absolute value ever is needed. If the index is odd, we will never ever need to use the absolute value. The answer will always exist. An odd index is what I call friendly. No restrictions here. Whatever goes, everything can go in there. And no restrictions here. That's the easiest and the nicest case. Odd index, no headache. Well, there are 2 other options here. For an even index, I can only have positive or 0. And if the answer is something like x squared or x to the 4th or x to the 6th or x to the 10th, in other words, this is only and always positive, I'll say no need, no absolute value needed. So if the index is even, I wait till the very last step, till the very end, and then I say, can the answer be negative? Then put the absolute value on it. Can the answer not be? Will the answer never be negative? Then there is no need for absolute value. And here's the third option. When it's an even, positive or 0, if the answer can be negative, then I have to use the absolute value. If this can be negative. And now we can look at examples. From 43 through 54 on page 594. I'm going to start with problem 50, in which I have the 5th root of x to the 5th. First of all, which of these 3 cases are we looking at? Case 1, 2, or 3? So what is the answer? That's it? I don't have to think. What about 51? The square root of x minus 5 squared. Let's find the answer first. The answer is there is something. Good. Now I have to think. Which of these 3 cases am I looking at? Definitely not the first one. Which of these 2? Is it this or this?
Okay.
The bottom one. What does that mean?
Can be negative.
48 The fourth root of 16x to the fourth. I recommend split it. The fourth root of 16 and the fourth root of x to the fourth. The reason why I recommend you split it is because you will see later in certain examples, if you don't split it, you may not be aware of what's happening. So I recommend it. So now I'm using two rules, right? I use the rule that splits because it's a product, splits the radical, and the other one I have to simplify here. So what do I get here? 2. And what do I get here? And now I have to stop for a moment and think, which of these three cases are we looking at? First of all, obviously we rule out the first one because the index is even, correct? So we're looking at case 2 or case 3? Exactly. Exactly. Because x could be negative. X squared, x to the fourth, x to the sixth, x to the 10th will never be negative. Yes, please.
So if we multiply, we only put the absolute value around the x.
That's why I need to split it. Yeah, because 2 does not need an absolute value. So if I hadn't split it, I would have put the absolute value on 2x. But there is no need on this. The only discussion is here. Good. What about 53? The square root of x squared plus 4x plus 4. What do we do with this? Wonderful. How come that I cannot do this? This is what I want to do.
Because you can split it.
Of course. This was the third property. Please remember it. This is a horrible mistake. Absolutely horrible. And we mentioned it here. If the radicand is a sum of terms or a difference of terms, you can never split the radical. So please do not ever write something like this. Thank you. Very good. So, and we have a contract on this. We signed it about a month ago.
This is where you factor it.
Exactly.
So the square root of x plus 2.
Very good. So now, what is the answer?
X plus 2.
Now I have to think. I have to go back in my mind to these three options, and I have to decide. Is it option 2 or is it option 3? It's option 3, which means I have no choice but use the absolute value. Now I want to make one up. The fourth root of x to the 16th. And I'm telling you that x can be any real number. X can be any real number. So what is the answer? X to the? Perfect. Now I have to analyze this. I have to analyze which case it is. Is it case 2 or is it case 3? It's case 2. X to the fourth will always be positive. It will be redundant to put the absolute value. It doesn't need it. X to the fourth will always be positive. So that's why I will not. It will be a mistake to put the absolute value on x to the fourth. Okay. 76. I know you're probably asking, where are we getting or going with this? You will see, but it will take a while till I will get there. Okay, now I see this is a ratio. I'm allowed to split the ratio. I recommend split the denominator because it's a product. And this problem in 76, it says it represents positive real numbers. So it means don't worry about the absolute value. So what will be the top? What will be the bottom?
34.
Very good. And this is it. Okay, I would like now to, since we know how to graph a function like the square root of x plus 3, we did that. I would like now to graph f of x equals the cube root of x. How many functions we know how to graph so far? The linear function, the absolute value, the second one, and the square root. This will be the fourth function, the cube root. Okay, what is the domain? Because remember, this is crucial. If I don't determine the domain, I will not be able to start graphing it. Yeah, I'm going to grab the calculator, but I'm not going to think about anything. Just going to grab the calculator and graph it. What will be the domain? Let's think. Can I take the cube root from -8?
Yeah.
Yes. Can I take the cube root from 0? What number I raise to the third power to get 0? 0. Can I take the cube root from a positive from positive 8? So if you remember, where did I write that? Right here. Look what I said about the odd index. Thank you. Odd indices, no problems, no headache. They are so good to us. Friendly functions. So negative infinity to infinity indeed. And I just gave you a few ordered pairs, a few x values, I should say. Here they are. Of course, I didn't choose 9 because I have to use a calculator to find the cube root of 9. I chose -8, friendly, -1, nice, 0, 1, and 8. So in this function, please plug in -8 and say the answer is -2. Please plug in -1, which number I raise to the third power to get -1. Very good. Plug in 0, plug in 1, plug in 8. Excellent. Nice function. Symmetric too. We haven't talked about symmetry in this class yet. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 1, 2. So the first ordered pair, -8, -2, right here. -1, -1, right here. 0, 0, right here. 1, 1, and 8, 2. So please pay attention how I graph the cube root. Careful. Of course, it's not a straight line. Very similar to the square root, but not exactly. It's not a straight line. So this is the cube root of x. Can anyone give us the range? Before you say anything, you know that this is the domain, and you know that this is the range. Right. All real numbers. So now we know how to graph the cube root of x. Any questions? Okay, I have 8 more minutes. I promise to stop in 8 minutes. I want to show one thing. We know a lot of exponential rules, right? If I multiply 2 exponential notations with the same base, I copy the base, and what do I do with the exponents? If I divide them, subtract. And if I raise to a power, multiply. If the exponents are fractions, the rules are the same. So when I multiply two exponential notations, I add the exponents. When I take to a power, I multiply and subtract. 8 raised to 0 is 1. So this is on page 598. And a negative exponent is 1 over a. Okay? So these are the same rules that we used for integers. We will be using for exponential notation, for exponents that are fractions. The exact same rules. No change there. Okay, so now I would like to look at page 601. So this is 10.2. Okay, use radical notation to write each expression. So I'm going to start with number 8 on page 601. 81 to 1/4. They want us to change this into a radical notation. What index will that be? The index will be 4. So this is the 4th root of, if I can simplify it, I should. Is there a number that I raise to the 4th power to get 81? Problem 12 on the same page. 16x to the 8th, everything raised to 1/2. What power is, or what root I should say, is power 1/2? Square root. So this is nothing else but the square root of 16x to the 8th, which I can split into the square root of 16 and the square root of x to the 8th. So the square root of 16 is 4. And now I'm applying another rule that allows me to simplify the square root of x to the 8th as x to the 4th. Any questions? Yes, please. Very good. I'll see you on Monday. So negative 32 raised to 1/5. What root is this? The 5th root of negative 32. Can I find, is this legitimate? Is this possible? Yes, because it's the 5th root, right? So can I find a number that I raise to the 5th power that will give us negative 32? Negative, right? Negative 2. Now they want us to go backwards. Use radical notation to write each expression. 24. 2x to 3/5. They want us to write this using a radical. I have to copy 2, and then the 5th root, yes, of x to the 3rd. X minus 4 raised to 3/4. Can anyone change this into a root? Very good. One more and I'll stop, I promise. 30. 64 raised to negative 2/3. Before we simplify this, let me remind you, a raised to a negative exponent is a fraction, which is 1/a to the positive exponent. We agree? Okay, perfect. So this is 1/64 to 2/3. So it's 1 over the cube root of 64 squared. Any questions? I just want to simplify this. There is one more step here. So I can rewrite this expression as 1 over the cube root of 64 squared. How much is the cube root of 64? That will be the square root. Yes, it's 4. So 1 over 4 squared, which is 1 over 60. Very good. I'll stop here. The homework will be due on Wednesday, a week from today. It will be from chapter 9, 3 sections, and just 10.1, not 10.2. We did not finish that. Let me remind you about my Labs Plus if you are doing your homework, so please do it every day. Thank you. If you have any questions, yes. Oh, thank you.